Yes, it is. And I figured this would be a good time to do 100+ applications of radiation and nuclear technology. First off, we'll go ahead and talk about how is it used in paper making. So this application isn't just for paper making, it's also used in aluminum and other things that you want to make thin and you want to have with precision thinness, and you want to make a lot of it. So here's an example of a setup of using this radiation to control the thickness of, this is like a metal here, but you have a strontium-90 source, which is a beta emitter. It's a very strong beta emitter, and you can see that not all of those betas are making it to this detector. You could take that detector, you hook it up to a thing to control a certain set point, and you want to see a certain amount of beta particles making it through. As some of you might already know, it doesn't take much plastic or paper or metal to block beta radiation. So if this paper or metal got too thick, it would dramatically reduce the amount that's detected on that detector. And if that got too thin, you could increase the amount of beta radiation that's making it through into that detector. So here is an animation showing that happen. You can see the amount of radiation making it through is too high because it got too thin. Sent a signal to basically increase the distance of those rollers, which makes it get thicker. You can see right there. If you set this up right, you can actually make it to be a very precise thickness. And you can see right here, the needle's starting to get to where the amount of signal is way too low because it got too thick. So it makes those rollers get closer to each other and makes it a very specific thickness. And what it showed there was a little over exaggerated. It would be a lot smaller of changes, and with radiation and a detector you can detect those small changes.